So at last, this is my final video in this series of integrating algebraic fractions. And I want to look at integrals that look something like this. So something where you have like x to the power of something on the top, and then something like this where you've got another power term plus a constant on the bottom, or that term on the bottom, that expression could be raised to a power like that there. So we'll go through a couple of examples. So example 1, let's integrate this here. Now the way we're going to integrate these fractions, we're going to let u be equal to the denominator. So we're going to do an integration by substitution when you get a question that looks something like this. So again, our method, we let u be equal to the denominator. And what we want to do then is we want to differentiate this u with respect to x to try and eliminate this dx and swap it with a du. So now let's differentiate this formula here. So du by dx is going to be equal to 6x. Therefore, that means that dx, just by swapping the dx with the 6x, we get dx is equal to, du, du over 6x there. So our integral is going to become 2x to the power of 5 over u, because that's u. And then we know that dx is du over 6x. So write du over 6x there. Now what we can do is just cancel out some of the indices here. So we've got 6x on the bottom, and then we've got on the top here 2x to the 5. That's going to give us 1/3 x to the 4. So again, we're going to get x to the power of 4 when we take away the indices 5, take away 1 and 1/3 at the front. Now the issue here, we're integrating with respect to u, but the problem is we still got this x term in our integrand that we need to somehow eliminate. Now the trick with this is you need to go back to your substitution, and what you need to do is try and get a formula here for x squared. So we know that u minus 5 is going to be equal to 3x squared. Let's just divide by 3. So u minus 5 over 3 is equal to x squared. Now we're trying to eliminate an x to the power 4. How do you go from x squared to x to the power 4? Well, you square both sides. So let's just square both sides of this equation there and there. So if we do that, we're going to end up with x to the power 4 here. And then here, whatever this is, so u minus 5 to the power of 2. And then divide by 3 squared, which is 9. So we end up with something like that. And so now the integral becomes 1/3. X to the power 4 is this thing here. So let's write this here. So u minus 5 to the power of 2 over 9. And then divided by u. So we'll just put a u under there. And then with respect to u. So now we've eliminated all the x's. And we've just got an integral here involving u, which is what we want. So now the integral looks exactly like the type of integrals that we looked at in video 7 in this series, so the previous video in this series. We just want to expand the brackets of the top. So we do that, we get, let's just bring the third to the front here. Let's just bring the third outside of the integral sign. So expand the brackets, u to the power of 2 minus 10u, and then plus 25. And then divide that all by this 9u here. And then we can split up the fraction into 3 individual terms, 3 individual integrals to integrate. So when we do that, we get something like this. Now we can just simplify the indices here. So we're going to get u over 9 here. We're going to get 10 over 9 there. And we're going to get 25 over 9u there. So now we end up with this. Now we can do the integration. So add 1 to the power, divide by the new power. So we're going to have 1/3 at the front. And then we're going to have u to the power of 2 over 2. So u to the power of 2, 9 times 2, that's 18. So divide by 18. Here we've got minus 10 over 9u. So minus 10 over 9u. And now this is the hard bit. So 25 over 9u. If you go back to video 1 in this series, you should know how to integrate that. That is going to give you 25 over 9. So plus 25 over 9. And then now we're integrating 1 over u, which is ln modulus u. So ln modulus u, close brackets, and then plus c, because we have no limits on the integral. But of course, as a final answer, what you should do is you should go back to the original u, this u there, and plug it into the final answer. So I'm not going to waste my time doing that. You just go back to this formula and you plug it every time you see a u. So you need to do that for your final answer. So now let's look at a second example, very similar to the previous one, but this time the denominator is raised to a power of 3 over 2. The process is again the same. We're going to use integration by substitution, and u is going to be the thing inside the bracket. So this expression inside the brackets, you don't involve the power. Because it's a reverse chain rule, you don't want to involve the power there, just the function inside this powered function. So now we can differentiate, so du by dx is going to be 2x, so just 2x for this one. So therefore we know that dx is going to be equal to du over 2x just by swapping the 2x with the dx. So combining this result with our integral here, so we know that the integral is equal to x to the power of 7 over u to the power of 3 over 2, so u power of 3 over 2, and then dx is equal to du over 2x. So we can do a very similar thing before, as we did before with the previous integral, where we just cancel out some indices. So we end up with the integral of x to the power of 7 divided by x. That's x to the power of 6 using indices. You've got this factor of a half, so this 2 on the bottom. I'm just going to put the half at the front there, so 1/2 there because of the 2 on the bottom. And then we've got this u to the power of 3 over 2 with respect to u. Now again, we run into the same issue as what we did before, where we're integrating with respect to u, but we still have this x variable inside the integrand. So what we need to do is go back to the substitution formula that we used before, and we're just going to try and come up with a formula in terms of u for x to the power of 6. So what we want to do then, take away 7 on both sides, u minus 7 is equal to x squared. I need a formula for x to the power of 6. To go from x squared to x to the power of 6, we need to raise both sides to a power of 3, okay? Because using indices, x to the power of 2 to the power of 3 is x to the power of 6, which is what we want in the first place. So we end up with something like this. There we go. So we know that x to the power of 6 is equal to u minus 7 cubed. So now we can write the integral down here. So this is 1/2 integral of this thing, u minus 7 to the power of 3, because that is x to the power of 6, and then divided by u to the power of 3 over 2 with respect to u. Now what you can do on the numerator, you can do a binomial expansion to expand the brackets on the top here, or you could do triple brackets. I mean, whichever you find quickest. It's probably going to be quickest to use the binomial expansion formula, so I'll quickly do that now. So when you do the binomial expansion, you'll get something like this. I made an error the first time that I did it, so please do check my answer, just make sure I did the expansion right. I quickly did that in my head. So if we just simplify this integrand into 4 separate fractions, so split everything up into 4 fractions, you'll get something like so. So you get something like that, and now we can just simplify all the indices here. So u to the power of 3 over u to the power of 1.5, that's going to be u to the power of 1.5. Next one, we've got minus 21, and then 2 take away 1.5 is a half, so u to the power of a half. Next one, we're going to have plus 147, and then u to the power of minus a half this time. And then lastly, we've got here minus 343, and then u to the power of negative 3 over 2. And that's all with respect, if I can get grip on this paper, all with respect to u. So du there, and then now it's just really first year, so add 1 to the power, divide by the new power, so u to the power of 5 over 2, and then 2 over 5. Next one is going to be u to the power of 3 over 2, divide by 1.5, that's going to be 42 over 3, u to the power of 3 over 2. And lastly, add 1 to the power here. So we get u to the power of minus a half, divide by minus a half. That's the same as multiplying by minus 2. So minus 2 times minus 343, that's going to be minus 686. Sorry, my bad, positive 686 because of the 2 negatives. So something like that, and then plus c at the end to complete it. And again, if you really wanted to, you could expand the brackets, but that there would be our answer. And again, what you should do with this one, like we did with the previous one, for your final answer, you need to go back to your substitution. So x squared plus 7, you need to plug it back in here instead of your u's for your final answer. So don't forget to do that. Again, I'm being a bit lazy today. Just plug in your formula into your final answer to get your final answer. So don't forget to do that.